Hey Algebra 2, so far we've covered the substitution method to solve for two variables with two equations. Today's lesson is called the elimination method, or also the linear combination method, but I like to call it the elimination method. Well, with this one we handle it a little differently than we do the substitution method. So our first problem I'm going to do says 5x minus 2y equals 30 and x plus 2y equals 6. Well, instead of doing a substitution where you have to get a variable by itself, what we're going to do is we're going to add our two equations. Now, what we have to do is make sure that we have the same coefficient for one of the variables and opposite symbols. See how I had negative 2y, positive 2y? Now what I can do is just add straight down. So if I add straight down, I get 5x plus 1x is 6x. Negative 2y plus 2y actually equals 0, so those get eliminated. And I get equals 36. So now I'm just left with 6x equals 36. So I can divide by 6, which means that x is equal to 6. Okay? Now that solves for x, but we also need to solve for y. So again, I'm going to put over here our x coordinate. Now we need to find our y coordinate. So here's where we actually have to just choose which equation we want to plug the 6 back into. Now you can choose either equation, so I'm just going to use the one that has smaller numbers to make it easier. So I'm going to use this equation right here. So I'm going to say 6 plus 2y is equal to 6, okay? Because I like to use the smaller numbers. So when I subtract 6, I actually get 0. 2y is equal to 0. That's okay. 0 is a number also. Divide by 2, y equals 0. There you go. I know some people, you guys have the tendency to get a 0, so you say, oh, it's not possible. But remember, 0 is a number as well. So therefore, y is equal to 0. Let's see if that makes sense. If I plug a 0 in for y here, I get 6 plus 0 equals 6. If I plug a 0 into y here, I get 5 times 6, which is 30, plus 0 is 30. So there you go. So what you have to make sure, the main thing is right here, that you have the same coefficient, one positive, one negative. So let's do another problem. So the next problem is 6x plus y equals 12. X minus 2y equals 2. Now for this problem, we don't have the same coefficient for either the x or the y. So we can't just add it down, or else that doesn't help us at all. So we have to try to get this. That's an ugly looking 2 there. We have to get this y here to be positive 2y. Because if we can get this to be 2y and this to be negative 2y, which it already is, we can eliminate those. So what we're going to do is we're going to take our top row and multiply the whole row by 2. We're going to distribute to each term. So that gives me 12x plus 2y is equal to 24. Just going to go ahead and rewrite the bottom row. So again, now we have a positive 2, now we have a negative 2. So those can get crossed out. We're just going to add down 12 plus 1 is 13x equals 24 plus 2 is 26. Then we solve for x by dividing. So x is equal to 2, which is good. We have our x. Now we need our y value. So we're going to go over to our original equations. Okay, let me get this out of there. Now, I'm going to choose the bottom one because it's dealing with smaller numbers. So unplug the 2 in there. 2 minus 2y is equal to 2. This one also, this is just by coincidence. It's not that every problem ends up with a 0, but this problem ends up the same way, where it's negative 2y is equal to 0. Divide by negative 2, y is equal to 0. So there will be problems that have different numbers than 0 for y, but in these two cases, that's what we ended up with. So again, what we did, if we have a negative 2y, so we need a positive 2y. We could have done the same thing with the x. If it says positive 6, we could change the bottom row to be negative 6. So we have to choose the x or y to eliminate. Now there's two special types of, just different type of elimination problems that you might come across. One like this, 3x minus 6y is equal to 7, and negative x plus 2y is equal to 6. So we're going to do the same thing we've done up there. We don't have the same coefficient, so we need to get the same coefficient. So we have a positive 3x, we have a negative 1. If this was negative 3x, then we can add down. So we're going to multiply the whole row by 3. Okay, so we're going to distribute to all the terms. So you get 3x. I'm just going to rewrite the top row. Now the bottom one you distribute, you get negative 3x what is that? Plus 6y equals 18. Now when we add down, you get 3x minus 3x is 0. That actually cancels out too. So we have 0 plus 0 equals 25. Well, we know that 0 does not equal 25. So when this happens, our final answer we put is no solution. That would be your final answer. And what does that mean? That means no matter what x and y value you plug into one of these problems, it will not work on the other equation. Every single time. No matter what x and y you plug in on the top, equation will not work on the bottom, and vice versa. So that's the one interesting problem here that you're going to get different from the first two examples, is when it's not equal to. Now the other, our last problem, it says 5x minus 3y is equal to 8. 10x minus 6y is equal to 16. Okay? So now, again, we want to get the same number, just opposite symbols. So I'm going to go with this 10 here. I have a positive 10, so I want this to be negative 10. So I'm going to multiply this row by negative 2. Again, the reason why I did that is so I can get a negative 10 on top. And I distribute to all three terms. So it gives me negative 10x plus 6y equals negative 16. Negative 16. Rewrite the bottom. 10x minus 6y equals positive 16. Now, there's something interesting that happens here. When I add down, these cancel out, I get 0. These cancel out, I get 0. But these also, I get 0. So now I'm left with 0 is equal to 0, which is true. So my final answer here is infinite solutions. So if everything cancels out and you're left with 0 is equal to 0, you have an infinite amount of solutions. That means when you go back to your original problem, no matter what you plug into x and y on the top, it'll always work for x and y on the bottom. For our first two examples, notice we can only use one set, 2 and 0, to work for both. What this one is saying that no matter what you plug in for x and y, as long as it works on top, it will work on bottom as well. There's an infinite amount of possibilities to make this true. So that is the elimination method. I hope you followed along clearly. And yes, I hope you're having a great day, and I hope you're enjoying watching this video. Of course you are. You get to watch math. I know you're excited about that. Okay, goodbye.